Hey guys, for today's episode, I wanted to do a little bit of a special intro just because this is an episode unlike anything we've had thus far. Dr. Kurt Woeller, our guest, is an incredible wealth of information, and he's talking about his and coincidentally my favorite topic in health, mitochondria. The reason I'm doing this intro is I want to set the tone for everyone. This is a deep dive. I mean, deep to the point where if you want to crack open a biochemistry textbook and look along as he's talking, it may be helpful for visual reference. We're getting into the specifics of what they are, how do they work, why do they work, and then we're doing a second part. So we're splitting it into two, so it's not too much to digest at one time, where we're going to get into aspects of knowing how to take the information regarding mitochondria and their function and relate it to clinical, practical things that you or your clients can actually latch on to. In addition, having the ability to actively and practically affect improving mitochondrial health. So, this is a two-part. For the brave ones, put your propeller hats on. It's going to be amazing. For those who want to upgrade and geek out, this is going to be right up your alley. Super excited for this episode with two parts with Dr. Kurt Woeller. Welcome back to the Following Your Gut podcast, where health science meets clinical wisdom. And the last time I spoke with just this gentleman, rather, I said to him, man, I feel like we should do a part two. We should definitely continue this conversation. And lo and behold, here we are. So we have back to the master supplements world, Dr. Kurt Woeller, but it's the first time you've been on this podcast. So, Dr. Kurt, you're a DO, you have an education academy, you're a consultant for Mosaic Lab. So if anyone's done a organic acids tutorial video, they know your voice already. You work with people clinically, you specialize in the autism community. I'm sure there's so much more that you actually do that you can tell us about. But first and foremost, how you doing?
I'm doing good, man. How are you?
Life is good. It's a gray day here in Georgia. What's the weather like on the West Coast?
We're getting some snow, which is
Hold
necessary
on.
in this.
Snow? Dude, I'm a recovering Canadian. I'm not ready to hear the S word yet.
Well, it is February in the Northwest, so I do like the snow and cold of February. So we're getting plenty of that. And
There you
but
go.
it's a beautiful area, and I know it's also a beautiful area where you are as well.
It is, but what better thing to do on a either snowy or rainy day than to have a really good conversation about health? So thank you for being here.
Absolutely, my pleasure.
So before today, we talked about the possibilities of a conversation. And you said one of my favorite words. I got really excited, but I tried not to show it on the phone. You said the word mitochondria. And I think it's probably fair that if people have propeller hats, you can put them on today because they might be appropriate because Dr. Kurt likes to go deep and for good reason. There's a lot of incredible insights he has. Uh, I want to know what it is about mitochondria really right now that's compelling you to want to talk about that, or what about them are you working with or working on?
Well, I've been looking at mitochondrial issues for a number of years, and the more that we work in this world of functional integrated medicine, you start to realize that the mitochondria are at the center or near center of so many different types of chronic health issues, but also really from a perspective of just health, fundamental for maintaining health and longevity. And one of the things that I didn't appreciate early on with regards to my initial study of mitochondrial function, because we all get basics of biochemistry if taken a course in college, even going back to high school biology, you're going to get some introduction into the mitochondria. But in medical school, you don't get a lot. You get a biochemistry class, and then that pretty much doctors at that point forget about it. But what you start to realize is that the mitochondria is framed as the energy factory of the cell, which it is, right, producing large amounts of ATP. But it also plays a major role in other cellular function, maintaining calcium regulation, maintaining other aspects of cellular biology. And so it's a dynamic organelle that is central to cell function, organ function, and our health. And when there are problems at the mitochondrial level, it can manifest in many different ways that sometimes people just don't recognize. And honestly, even a lot of medicine doesn't recognize. They have to think that some kind of mitochondrial dysfunction has to be some serious disease state. But even just kind of subtle or imbalances can many times have profound effects for people.
Oh, that's incredibly wise to say because we assume it's kind of like a light switch, right? It's either energy or no energy, but there's varying states in between. And something simple as, let's make it practical, brain fog could be a mitochondrial problem in a part of the brain. Chronic aches and pains and tightness could be a mitochondrial issue in connective tissue. So that's really wise to say. And what's interesting is a lot of people I don't think consider the role of mitochondria with the digestive system. They think of microbes and the microbiome, but very few people talk about these things because, from my understanding, or correct me if I'm wrong, mitochondria used to be a bacteria. Billions of years ago, they were a separate aspect of the eukaryotic cell, correct?
That's correct. At least there's a couple theories. One of those is that going back, I think over 1.5 billion years ago, there was a either an infusion of bacteria, perhaps into other bacteria or into other cell forms. I think the theory is called endosymbiosis, but it's a
Mm-hmm.
symbiotic relationship. So it's very interesting when you think about mitochondria from that perspective. In fact, I was just thinking about this morning when mitochondria coming from bacteria and then obviously having their own ability to metabolize different things for energy production being incorporated into another cell form and then supporting that cell form in its lifespan. And if we think about the microbiome, right, we talk so much about gut bacteria, and that's the prevailing organism within the digestive tract, are these different bacteria. Well, they themselves have their own energy production capacities, but they also produce compounds that then support our own mitochondria at our own cellular level. And so, if you think about it, just going back to that early symbiotic relationship, making that connection between our mitochondria and the bacteria of our digestive tract makes for a really interesting way of just thinking about another angle of the microbiome and its influence on our overall health.
Mm-hmm.
So, for example, if you study the biochemistry just from glycolysis to fatty acid metabolism to amino acid metabolism and how things segue down to a mitochondrial level, there's different, obviously there's different pathways, there's different doors that, enter the Krebs cycle and then activate, energy mechanics along the electron transport chain. But we have to get those nutrients that support mitochondrial function, obviously from our diet. Now, we can produce some of those things internally within our body, but many of those things that we get from our food are also then processed or made available by gut bacteria. So there's a relationship of the nutrients we get from food, how they're processed by our microbiome, and then made more available to us for absorption and then incorporation into those cellular mechanics for mitochondrial activity. But expanding it from there, you also get into other types of chemicals that are produced that have a profound effect on mitochondrial function, specifically the short chain fatty acids, which I know, Roland, from your perspective and what you know too, in working with people with gut health and working with probiotics or diet and whatnot, I'm sure you have a lot of knowledge and experience with and sort of the beneficial influence of these intestinal microbes in producing short chain fatty acids. So it's often an overlooked area in medicine, but it's becoming a fundamental area of understanding in the functional integrated medicine world.
Oh, bang on. I remember reading something that blew my mind many years ago, and I've never forgotten, is that the short chain fatty acid butyrate is one of the main communication molecules used by the microbes to signal and speak to the mitochondria of the cells of the colon or the epithelial lining. Because the one thing I think is worth saying that I have been guilty of in the past when I started learning about this stuff, we think mitochondria, we think energy metabolism, and I think a lot of people associate exercise, muscle, mitochondria, things of that nature. But very few people realize that the quality of the energy production in every single organ is dependent upon the mitochondrial health of that organ. So for a liver to detoxify well, the hepatocyte mitochondrial function has to be strong. There's a lot of density of mitochondria in a liver cell. For your digestive cells to absorb things properly and be able to transport that nourishment through the gut into the bloodstream, so all of the mitochondria in the body are getting a fuel source. the mitochondria of the epithelial cells have to work properly. So that communication and crosstalk, and this word I love, this interconnected play of all things in physiology are super important. I wanted to ask you, because I'm thinking what might be a really good track to go here is start wide and go narrow. You mentioned imbalances, slight dysfunctions at their core could really be mitochondrial problems. What are some of the things that you have either seen clinically or experienced clinically or read about from a fundamental level that are common mitochondrial issues that you think people might not actually know of or
Well,
associate with?
let's take out of the discussion mitochondrial diseases, for example. And I don't want to take them out entirely, but just from a genetic standpoint,
Like an
because obviously,
inborn error of metabolism, you're saying.
yeah, the genetics
Yeah.
of the mitochondria are very complex. And so, most of the mitochondrial components are actually produced from nuclear DNA or the template of nuclear DNA. Some are actually produced from mitochondrial DNA. And so you certainly have a subset of mitochondrial diseases that can manifest in a very, very severe way. Now, I still happen to believe that even those individuals can get some help and support by eating healthy, living a healthy lifestyle, healthy microbiome, etc. Many more people have a mitochondrial dysfunction that could be induced from various lifestyle factors, uh, eating poor quality diet, too much alcohol, lack of sleep, environmental exposures, multiple things that we're exposed to environmentally can negatively impact the mitochondria in various ways. Um, back to your point real quickly, and we'll continue this. One of the things I want people to understand and think about from a mitochondrial standpoint is the organ systems in our body that are most metabolically demanding. So the brain and nervous system requires about 20% of all of the ATP that we produce at any given moment. So you and I sitting here having a conversation, our brain and nervous system is demanding massive amounts of ATP to just
Mhm.
have a conversation. Cardiovascular system, even just sitting here in my heart pumping and moving blood throughout my body is requiring energy. Musculoskeletal system, all of that is under high demand. You mentioned the gut. When you actually look at the list of many mitochondrial diseases, they typically manifest with neurological problems, cardiovascular issues, kidney issues, liver issues, gastrointestinal problems, and many times visual issues. So these are very high demanding organ systems in our
Mhm.
body. It's interesting about the gut because you're absolutely right. In order to absorb, sometimes you get some passive absorption of nutrients, but essentially, gut function is an active process. The movement of things through the digestive tract, the peristaltic movement, is an active process. So we have to have mitochondria replete within the epithelial cells and other cells that are producing mucin and other immune factors. Another area where mitochondria are massively needed is in the immune system. If you have poor mitochondrial function, it will not only affect innate but also adaptive immunity. And we know that the gut is the largest immune organ in the body, essentially the surface lining of the gut, that first line immune defense. Well, in order to combat pathogens in the gut and produce the immune chemicals that we need to neutralize pathogens, you need good mitochondrial function. And so when I think about patients with just varying different types of health, conditions, I'm always thinking about how the mitochondria might be playing a role in some of their issues. Some people, it might be brain fog, as you mentioned. Others, it might be sleeping problems. Others, it could be anxiety. Others, it may just be purely a digestive system problem or weakness or um, generalized fatigue, which would certainly make sense. And I think I went off, I kind of went off on a tangent, and
No,
I
you're
actually
good.
forgot.
I'm
I
following
forgot.
you because we're gonna bring it back in.
I forgot was the primary question you asked. So rephrase that
You
question again.
basically you just answered it for me because it was how do these things practically show up? One thing I
Right.
love to do is take something that sounds like a very complex abstract concept and make it either an example, a picture, a visual, a practical understanding. So you just did a really, really amazing job there where you have basically said that all metabolically demanding organs, and we say metabolically demanding, I'll further define that in my own way as organs that have a high density of mitochondria in them. Is that a fair statement?
Yes. Yes.
So they're more sensitive to having a lack of energy disrupt their normal function vis-a-vis a symptom being manifested that a person experiences. So by the sound of what you said, people who experience those kinds of issues and many, many, many more, it's an energy problem at the end of the day. And what I love about what you said is something that I've been working on as a conceptual framework for explaining things. To me, all disease is just an energy problem. And I don't say just to say it's simply that thing, but from a 30,000-foot view, all imbalance leading to symptom manifestation, leading to pathology, is a progressive loss of energy and adaptability. Because to recover from being sick takes energy to fight off the threat and then rebalance the homeostasis of the body. So, from a practical level, I think what's really useful for everyone to take away from here is sometimes in health, we get bogged down by we have to kill the microbe, we have to eradicate the virus, we have to detoxify the toxin. That is driving the mitochondrial dysfunction, or a combination of those things are what is actually causing the manifestation of the issue. But for the body to heal, it's not simply removing the threat, it's supporting its ability to produce energy to resynthesize tissue and regenerate function that ultimately is dealing with the dysfunctional mitochondria. Is that a fair way to round it out?
Yeah, that's a great way of explaining it. And, you mentioned about microbes as I was talking about just, immune function. A particular immune cell requires a lot of energy. And I think the whole point is to understand that energy isn't just, oh, I can go run a marathon.
Hmm.
It's the energy is I can function normally
Yeah.
in my daily life and daily existence in willful acts, but also just the inherent wisdom and drive of my body is dependent upon these small, very robust, very complicated organelles that play a pivotal role. And as I mentioned before, it's not just about energy production. These things play a role in cell signaling, in cell cycle regeneration and regeneration, essentially of tissues. So they're massively important. And the other thing I have to think about too, Roland, with regards to this discussion is that when we are engaged as human beings in just daily existence, there is a high demand on our system for nutrition and nutrients. Because in order for these mitochondria to go through their different chemical steps, they need nutrition, various B vitamins, for example, antioxidants. All of these things are absolutely essential. And if you don't have a healthy diet, okay, well, you're going to be compromised long term. And this is, plays out when you just look at certain very um, well-known diseases, from pellagra and these, beriberi and these types of things.
Mhm.
But the other thing is the aspect of how important a healthy digestive system is. Because if we have dysfunction in the gut, okay, if you have, let's say, an overgrowth or an overexpression of certain fungus, candida, for example, which is a normal inhabitant of the digestive tract. However, in an overgrowth state, it can produce different compounds that can interfere with certain necessary nutrients. So, for example, candida can produce compounds that inhibit thiamine absorption. They can produce compounds that can lead to B6 and lipoic acid deficiencies. Well, those have a fundamental role at the mitochondrial level. Certain bacteria in the digestive tract, even normal bacteria, produce these short chain fatty acids. You mentioned butyric acid, which is not only incredibly important within the gut, particularly the large intestine, but it has a fundamental role, a cell signaling role, throughout our body. And what a lot of people don't realize is that butyric acid can actually help rescue a faltering mitochondria in its ability to make more energy and make more ATP. So this has been well studied in the autism world, for example. And so in a lot of the autistic kids, let me close something out here real quick. Have a lot of these autistic kids tend to have mitochondrial problems, some of it intrinsic to the mitochondria, but a lot of it exogenously induced. So that could just be because they've got, nutrient deficiencies because of poor eating habits or absorption problems or environmental, chemicals that they're exposed to that they can't detoxify. And what they have found is that overgrowth patterns within the digestive tract of certain bacteria can create certain short chain fatty acids that have a competitive aspect on mitochondrial function. So, for example, Clostridia bacteria. So, you probably talked about before about overgrowth of Clostridia difficile, which we know can be obviously a pathogenic Clostridia bacteria in the gut. But there are many different types of Clostridia bacteria, and Clostridia bacteria actually make up a significant percentage of the backdrop of our microbiome. I think it's about 40%. But those Clostridium bacteria in general produce different fatty acids. So they can produce butyric acid, but they can also produce another acid called propionic acid. And what's interesting in that discussion in certain sensitive individuals like autistic individuals is both butyric acid can have a bolstering effect on mitochondrial activity. It sequences through acetyl coenzyme A, which then enters the Krebs cycle and then from there engages the electron transport chain. But if you have too much propionic acid, well, it too can induce mitochondrial activity by engaging the Krebs cycle. But if it's out of balance with butyric acid, it will actually inhibit butyric acid's function and can compromise Krebs cycle activity where we're not getting the same amount of ATP production in a highly induced propionic acid state.
Mm.
And so all of these short chain fatty acids can have some benefit, but in certain susceptible individuals, too much of something can also then have detrimental influences, even though it might be a normal compound. So a lot of times the discussion of mitochondrial issues comes down to the type of patients you're working with. And they've looked at this research of butyric acid, propionic acid pretty intensely in the autism world, but it can also expand out potentially to other types of patient bases from other neurological issues to mental health conditions, for example. So it kind of goes back to the explanation that a well-established diverse microbiome is really the ticket long term to health, longevity, maintenance, and I guess increasing your odds of having a healthy long life and diminishing the potential for various disease states, which is so prevalent in today's world.
That was beautifully put at the end. And that's so interesting because I think another important yet practical takeaway is that something going on in your gut isn't just affecting the mitochondria in your gut. It will, but from my understanding too, mitochondria are networked. They are always communicating with each other amongst the entire organism. So something as simple as a gut microbiome imbalance can cause systemic mitochondrial dysfunction that shows up as a symptom manifestation in a very specific area. Let's call it the neurological system. And it could be something as simple as something an individual deals with on a daily basis, and they just think it's part of their normal. But at the root cause of it, it takes a really astute clinician to put the pieces together and reverse engineer that their gut rather is causing systemic energy problems.